Well, thank you for being here, and also thank you very much for CoorsTek being a big sponsor of this event as well.
We're happy to continue to participate in what you guys are doing here. I mean, I think you've heard it all throughout this morning and yesterday, the fabulous work that continues to go on, and your continued partnership with, I'll say, multiple tiers within society, because it really is going to take all of us to do some of the major challenges that we have in front of us.
Yeah, that's a great opening point, and I think for the audience, you know, I've always discovered some people know what CoorsTek does, and some people don't know what CoorsTek does. Obviously, if we walk out the front doors, there's a beautiful building sitting right there that has the CoorsTek name on it. That anybody here in the 50th anniversary class in the room, they'll be having breakfast in there tomorrow morning as the 5K runners finish. Are you running?
I am running.
Okay, all right. So we'll see you there tomorrow morning there as well. I saw you out there last year. So
yeah. Speaking of the building, I think it's kind of funny. Somebody put a lot of time and effort to go through the naming of calling it the CoorsTek Center for Applied Sciences and Engineering, only to get it shortened to the CoorsTek building.
Yes. as tends to happen with buildings around here. At least what people refer to it actually has some part of the actual name in it.
That's right.
Which isn't always the case around here. But so I mean, maybe spend a couple minutes telling people about CoorsTek.
Yeah. So CoorsTek is a global engineering ceramics company, and we aren't often what people think about when they think about large global problems, but as some examples, as we go to say where we've participated, particularly within the energy industry, is if you go to Edison's laboratory in Trenton, New Jersey, some of our ceramic, scientific, and chemical labware is in his laboratory. And so it's interesting to think about how, as he worked on fundamental material science, that really led to a boom in energy supply, and think of the light bulb and everything that we have technology-wise, Wi-Fi, that we maybe had a small part to play in his development as he went through thousands of iterations. You go from there to continued investment in, coal was mentioned. We have products that go into electrostatic precipitators, as well as basic things as wear tiles for some of that industry. And as we transitioned, some of the super secret stuff that we did, and maybe we don't even know, some of it's folklore at this point, is within the nuclear industry. As some of those things were being developed, there were some really hard challenges that were being solved during that time. And when you start to push the boundaries of pushing electrons in a certain way, or heat problems, all of those things start to outpace, I would say, more of your traditional materials as far as metals and plastics. And that's really where ceramics come into play. So we participated in the Manhattan Project. We continue to support the nuclear industry today through seals and neutron absorbers and those type of things. And then with oil and gas, again, it's an important part. And I know fossil fuels is moving and transitioning, but we've continued to support the efforts to not only get more energy through seals, through frac balls, through a number of downhole drilling components, to continuing to transition into the next generation of energy supply. So you think about photovoltaics. Again, it's a material science challenge. We participate in that field. Hydrogen, electrification, all of those areas. You think about power electronics. And then somebody mentioned data centers earlier. I mean, data centers are huge consumers of power. Within that is the whole semiconductor industry. And our big participation there in the semiconductor industry is continuing to help them do things better, faster, cheaper.
Right. So why golden?
Well, Golden is kind of where we started. Obviously, there's another big building that has the name on it here that's probably more people are more familiar with, and unfortunately, I think the short tour has been eliminated.
There was a lot of consternation on campus when that happened.
We continue to hear about that. No, I mean, I think, so part of it is there was an alumina supply here in Colorado that was being used for ceramic pottery and whatnot. And as some of the history goes, when we started getting into world wars and some of the chemical, scientific, and labware from Germany, from Asia, and other stuff was cut off, the U.S. government went around to potterers around the U.S. to say, who can make the right quality that we need to continue to do the development? And we happen to have the right supply. And since then, we've continued to iterate and develop, again, some of the material science fundamental challenges as the world continues to grow, as we continue to see the challenges of the future. To us, some of that material science is where we continue to put our energy. So a handful of years ago, we decided to put in our CoorsTek Center for Advanced Materials here in Golden. Part of the reason why we did it here is because we have a good connection with a lot of the other nexus of things going on between the School of Mines, NREL, and just the kind of the ecosphere, or the concentration of kind of knowledge and development that's happening here seemed to be the right fit.
That's great, yeah, and certainly from the university side of things, we've really enjoyed the partnership and the opportunity to be engaged in those things. Earlier when we bumped into each other out in the hallway, you mentioned about sort of spending some time sort of fixing things versus having things designed up front a little bit, and wonder if you could comment on that a little bit.
Yeah, so, as we've gone through the years, ceramics is not your cheapest material, and it's not always something that most engineers study or have historically studied in school. So when you go through your materials courses and whatnot, as it was said to me, a handful of years ago, you spend about 95% of your time on metals and metal alloys and all of that, a few percentage of your times on polymers, and ceramics might have gotten mentioned in there as, oh, by the way. But really, as the world continues to solve challenges, as thermal management, as pushing electrons, I've got a Ford Lightning, and so as you think about charging that, it still takes 45 minutes on a supercharger. There's a tremendous amount of electrons being shoved in there, and moving electrons creates heat, so it creates thermal issues and all of that. And so there's things that traditional metals and plastics can't do, and so we've really been thinking about how do we get ceramics as a more common material that people are talking about it. And you see it in industry as we're iterating and developing, but it's usually engineers come to us and say, well, we have this drawing, we've been doing this in metals or plastics, and it's not working. And so we have to work with them on redesigning, reiterating with them. And so part of it is, if we had more influx of, I say ceramic engineers, but people that understand ceramics and what ceramics can do from a material science side, that they start off designing things with ceramics in mind. It's not the right solution for everything, but if you at least have that as a tool in your tool belt, we feel that we can get faster to solving some of the very large, complex problems that we're having. So I know we've worked with mines over a number of years, and this year is the first year or second year that you have a ceramics engineering program, but you have those courses built around the material science, and ceramics is a key portion in that. So we thank you for that, and have enjoyed that partnership.
Well, we love that. And of course, Mines has always sort of been very in some ways industry-driven with respect to the programs that we offer and the input and everything. And I think that this was a great opportunity because I don't, maybe you know offhand, the total number of ceramics engineering programs in the country, but I think
there's very few.
I was gonna say it probably fits on one hand.
I was going to say I think we hire from about 2 or 3 schools. So.
Yeah, there's one in New York probably,
Yeah.
and there's the one here, and yeah, so there aren't very many programs, and we're very excited about it too because I think it's an opportunity for mines to really step up in front of everybody else, and with a partner like CoorsTek in our backyard, people are going to be willing to believe we've got the best one. So
Yeah.
it's a great way to sort of jump into that for us. So curious a little bit about your journey, and you graduated around 2000?
Yeah, 2001.
2001. I assume you didn't go from crossing the graduation stage to being co-CEO of CoorsTek. So what was in between?
Yeah, so I will say I was a 5th-year senior. It took me a little longer. The general premise was that I would go to a smaller liberal arts school and get some of the things that mines or other engineering schools back then didn't really provide, because as you progress through business and whatnot, you do more non-engineering type work. That didn't quite pan out, but timing-wise, it set me off. So I was a 5th-year senior, so that's also okay for those that are out there maybe who need some extra time.
Do we have any 5th-year seniors or former 4th-year seniors out? Yeah, there's always
Or I was a late bloomer. I don't know. No, I think by the grace of at least one, if not a handful of teachers, I somehow managed the gauntlet that is mines.
Yeah. We call them super seniors.
Super seniors, okay. No, so I graduated with a degree at the time called Chemical and Petroleum Engineering. I went to work for a small startup doing fuel cell research and development, which, as a lot of startups in that kind of fuel cell electrolysis, they kind of pop up and they come down, and we've been working on that for a long time. I moved into manufacturing, so I moved into the pulp and paper industry. Was trained as a Six Sigma black belt, so doing a lot on efficiency, production efficiency, energy efficiency. I did that and then moved into supervisory roles, quality manager, before I had an opportunity to move over to Sweden, where we made an investment in a paper mill, and my project there was to install about an $80 million waste-to-energy plant, which was a fascinating way of converting what would otherwise be landfill waste. And so it was a paper mill that took recycled material, separated out the plastic. We used the plastic along with other industrial waste to supply 100% of the steam and about a third of the energy. So that was kind of getting me back into engineering, but yet project management as well. When that time was up, I moved into CoorsTek, plant manager, general manager, and then stepped outside of that to run a sensors business startup. I agree with the comment about regulation. You know, regulation can drive business forward. It can also stop it in its tracks. And before moving into the co-CEO role. So, yeah, an interesting transition, but you know, at the heart of that was you know, the engineering background, which I think enables me today as we look at customers or other challenges that are being solved. Certainly you look at it from a business perspective, but you can also look at the technology and the science that's inside of it. And while I may not understand all the nuances, at least I feel like it helps me to be able to ask pertinent technology questions that then lead into business questions as well.
Okay, so you've actually been connected with energy for quite a long time.
I have.
With many of your parts of your journey, and obviously sort of the leadership development thing. You've mentioned the sort of the co-CEO thing. One of the sort of curious things, right, is you've got 3 co-CEOs of course. So how does that work?
I will say it works but you have to have a certain element of humility. If you've interacted with a lot of CEOs, we're all very driven and we're all very focused. The way it came about is we were brought back into CoorsTek at a time, and we each had different divisions or markets within that. And again, being very driven, it was like, oh, I need my own HR person. I need my own commercial person. I need this and that because I'm focused on growing my element of the business. And that had its merits. But as a smaller private company, there's an affordability side of that we sat down and we said, we can't keep going in this because we're basically triplicating a lot of stuff. And so that's when we got back together and said, okay, if we're going to do this, we're going to do this kind of together as call it the office of a CEO. But it takes a tremendous amount of alignment. And for us, it's alignment around strategy on how we're going to continue to develop and grow with key partnerships with both on the fundamental science side, but also with commercial partners. And so when we start having larger conversations, it's really about how do the three of us help triangulate around what that vision and strategy is. I will say the nice part is you always have somebody to talk to. Mm-hmm. The office of a CEO can be pretty lonely. You have your executive team, and you can talk to them about certain things, but sometimes you just need somebody outside. With us, there's always three of us, and we can debate, we can challenge each other, we can be the iron sharpens iron, and to me that has tremendous benefit and value. And I do think that you are seeing more and more co-CEO type models out in business. There are others, so we're probably breaking ground for three of us, but that idea of kind of co-CEOs is not uncommon. And for us, we kind of keep our direction intact by being precisely aligned around a particular strategy.
Yeah, I know there was a time where Motorola had two co-CEOs, mm-hmm. and they basically did it so they had somebody around the clock.
That is the other advantage. Usually somebody's in the office, and somebody could be traveling for business, somebody could be doing this or that. But it does take a tremendous amount of time and coordination. And so I usually tell people, if you want to know how it's going, ask our executive team. And if our executive team is happy, then we're probably doing okay.
Okay. So yesterday when Dave and Doug Lawler were sitting up here, they talked a little bit about sort of leadership skills and how they kind of learn from other people. I'm just curious on your co-CEO team, what's each person's leadership superpower?
Within just our co-CEOs? Yeah, I mean, I would say that we each have certainly different personalities. So two of us are engineers from mines, so we have more kind of an engineering personality. Jonathan is a political science major, and so he comes from a different perspective. I think that actually helps sharpen our discussions because we can, like I said, we can challenge each other on that. So from a leadership perspective, I think we will each usually play different roles, usually lending towards our strengths, but yet understanding where each of our weaknesses are. Usually, working on strengthening your strengths is important, but strengthening your weaknesses is maybe even more impactful. And so that's where the three of us can really work with each other over time of like somebody may be more comfortable in one setting or the other, but also challenging the other to step into certain positions at times to do that. So, and then that trickles down again into our leadership team, into our culture. We want people to be inquisitive, to be exploratory within the confines of a for-profit business, but changing the dynamics. I think it was mentioned earlier today of you get companies that tend to be dinosaurs, and they tend to want to iterate in a very defined path. I think is we're seeing the challenges of the future accelerate. Being able to challenge an organization, challenge yourselves and your leadership style to be able to incorporate that element of responsiveness and iteration is extremely important. So that does trickle down into leadership, because I think you lead differently than if you led just a big behemoth of an organization that the cogs in the wheel churn a little bit slower.
Yep. Now, CoorsTek is multinational.
Yes.
So people might be curious about where your footprint extends across the globe.
Over the last 15, 20 years, we've really been expanding through various opportunistic but also strategic acquisitions. So we've grown throughout Europe first, and then through Asia. So our footprint is heavy in Europe, but we're growing in Asia. And I would probably say more of our focus now is growth in Asia, as we see the continued investment, the mega trends as far as population growth and demographics. That's where population is growing, particularly Southeast Asia. So that's really where probably more and more of our focus on growth is going to be. So, but yeah, heavy in Japan, Southeast Asia, North America will still be a footprint for us, certainly with our headquarters being here. And then our footprint around, I will say, from the very north end, almost Arctic Circle end of Sweden, down into Germany and Czech Republic. And so, yeah, if you're interested in a global company, I know we were talking about engineers. We hire a lot of fantastic engineers that come from mines and get to explore the fundamental material science that goes into solving a lot of these world challenges.
Mm-hmm. So getting back to sort of the energy thing for a minute, one of the interesting presentations yesterday, Bruce Grucock talked a bit about, because he's from the construction industry,
Mm-hmm.
and so he sees the transition from the perspective of sort of delivering projects and stuff like that. I would think from the CoorsTek perspective, you can sort of see the transition from delivering products versus projects. And just wondering if there's any sort of like trends that you see in what your customers are looking for versus sort of what the headlines stories are about the energy. You might have a little different perspective at, sort of how the transition's actually happening from the demand for products for it. So I wonder if you had any perspective on that.
Yeah, so I mean, maybe more tangible when you talk about energy generation. Obviously, we've heard it today, but solar and wind as a percentage of our overall population of energy generation continues to grow. So part of that is, how do you reduce the physical barriers? I say physical, the electrochemical, the physics of rolling resistance in windmills. If you can reduce the rolling resistance, you can get greater efficiency. So we participate in those areas. We participate in the solar areas as far as the some of the siliconized silicon carbide components that go into the manufacturing of solar panels and all of that. And so from a product standpoint, you can definitely see how those industries kind of ebb and flow. We had a massive oil boom when the shale oil and fracking was in its heydays, not that many years ago. But then you could definitely see it fall off as we hit maybe our last recession, depending on where you want to put it on. So we certainly see the ebb and flow. I will say where a lot of the focus is on now is the amount of energy needed and the growth of that demand. We've talked about data centers. We've talked about how energy has kind of fluctuated downward and whatnot, but data centers are going to be a big driver of energy, and so the amount of electrons moving through systems are a challenge that needs to be designed in as far as energy losses and making things more efficient. And materials and material science, I think, is at the core of enabling a lot of that.
Awesome. So maybe to wrap up for the students in the audience and people here, having left here 23 years ago or whatever, any I don't know, advice for people starting off on their career journey?
Yeah, I mean, talk to any alumni. There's an element of kind of perseverance and persistence, because what we do as engineers is not easy. If it was easy, more people would probably be doing it. But because it's not easy, there's some really exciting things and breakthroughs that can happen. And again, not all breakthroughs are worth scaling to manufacturing, but it's that keep coming back and keep iterating, keep developing, because if you look at technological progress over the last 100 years, it's really amazing to see what has been done in the conjunction of the sciences, industry, and then how that has dramatically improved our lives over the last 100, 150 years that has never been here on this earth at any point in time. And so that persistence, that perseverance to keep coming back to challenges, looking at it in different angles, different ways, I think is a real key to getting through this energy transition and into what the next 100+ years looks like.
All right, great. Well, I appreciate your time today. We very, very, very highly value our partnership with CoorsTek.
Likewise.
We're very proud that CoorsTek is in Golden, and we're excited by all the things that it works on, and we love to have an opportunity to be connected with that. And of course, obviously, love to see graduates working there. So thank you for all that you do. Thank you for all that you do for Mines, and good luck tomorrow morning on the 5K. So
all right.
Anyway, please thank
you.
them. Thanks.